This is a demonstration of Wirecast. 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 This is a demonstration. This is a demonstration of Wirecast. 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 This is a demonstration of Wirecast.
Kali Linux, and I think even in Backtrack 3, 5, whatever. It has a content spider, it has a brute forcer, fairly solid brute forcer. We use Nikto, we use which can go through a lot of pages very fast for some kind of CGI testing. It's built in. It's an actual add-on for Nessus. It's port scanner. It's everything that you need in a
This
tool.
is a
How many of you
demonstration
are
of
actually doing
Wirecast.
the WordPress pages programming? Very smart. No, but okay, people tend to download stuff like that. So we have a VP scan, which identifies every VP hook, which enumerates themes, it enumerates plugins, usernames, checks all the content management systems. So basically, we have a wide spectrum of tools that we can actually use for automated scanning. I'm just moving through this stuff. If anybody doesn't know anything about it, or if you all know everything, we can skip it and deal with some interesting stuff. Okay, so some kind of tips. But I have like 8+ years in sole pen testing experience, and some kind of tips that are actually common sense, but people often forget, is always verify, for example, verify settings for automated scanning. If you don't do it, you will solely entering the URL and pressing OK could take hours, days, months, depends on the size of the app. Yeah, it can take months. If it's a big project, it can take whatever it is. Usually, users don't want for you to test against the DOS attacks. We all know what DOS is, yeah? Yeah, denial of service. So it can actually flood the server. It's not devastating as actual penetration, but it's actually unfunctional test that can crash the database and some kind of switches stuff. Well, it's more of a torture test than a stress test. We also need to not to use distributed denial of service and stuff like that. People often don't want you to test for password reset page they're asking you for to bypass some pages because, well, it's a sensitive info and nobody actually wants you to have a good look at every process of the application. That's how it works. And always need to have enough time to weed out all the false positives because there will be a lot of them all the time. So that's something like this. Then we go to the manual testing phase, which is actual penetration phase, where you need actually to see if automated test found some kind of results. If you're going by checklist, if that found some kind of result, you need to put it on the next, to bring it on the next level. So if, for instance, your scan said, okay, this page is vulnerable to SQL injection. You ought to use Nmap or whatever it is that you use, SQL map, whatever. You ought to use it to try to actually make the attack, to see how deep you can go, to see what damage you can cause, potentially.
This is a demonstration
and
of Wirecast.
What would you suggest to actually stop that? So that's why it takes a lot of time. You have to explore all the applications with tools, like all parts of application, even proxy, with use of programs like Burp Suite. You need to have some kind of content discovery, to use some kind of crawlers, spiders, whatever it is. Now I use always Bitbuster for finding some kind of files, and that's important for some new attacks.
This is a demonstration of Wirecast.
You always need to review the server response if it's actually giving back some kind of sensitive data. I once have a problem with SSL that was returning the actual expected key, believe it or not. So you try to log in, and the response, if you have a wrong password, is your password is not expected password. Okay, here it is, expected password. Come on. So you have stuff like that happen. Stuff like that actually happen. So we need to make sure that we can try everything, that we can actually try to do some kind of cross-site scripting, to do some kind of payload via any kind of injection, to try to make a cross-site request forgery, to try some kind of local file inclusion, to try some kind of remote file inclusion, to see if there is any dangerous method like in the code. If the application allows put or delete or switch or swap,
This is
it's a problem.
demonstration of
It actually
Wirecast.
is a problem because you can simulate the browser with the console and make whatever that is, damage that is. You need to actually check if sensitive data is being transferred in the URL with the request. If URL request contains or response contains session ID with the cookie, you have a problem. And that's something people, even in .NET, I know everybody
This
our
is a
best.
demonstration of
But,
Wirecast.
just .NET. Even in .NET, that happens. And that caused for a lot of actual problems. Once you start forgetting stuff, you open the door for a lot of creative people to exploit you. So, in the past times, we had people forgetting logoff function, causing a session not to be
This
ended
is
at
a
any point.
demonstration of Wirecast.
Since the press is now, well, everybody is insisting on two-steps authentication, some kind of tokens or timetables, for that matter. You have a problem because everybody can make mistake, and the cost of mistake in penetration, in security sense, the cost of mistake is much bigger than
This
actual
is a demonstration of
unfunctionality of the
Wirecast.
product. So that's why it's important. Okay, so we need to figure that the client side and the server side can be vulnerable. If we figure that, then we have to ask ourselves, is there a way to make a 100% secure application? Seriously. Okay, then we need to take a
This is a demonstration
closer look
of Wirecast.
to see if we know all the attacks. What are the most common attacks that you can find on YouTube and perform it relatively easy? And what are some more advanced attacks that you can try? So we're here today to talk about what are the most creative attacks that happens in past 2 years. So that would be
This is a
directory
demonstration
transversal,
of
that would be
Wirecast.
shell shock, that would be heartbleed, that would be new way of pass the hash online. The .NET. .NET. Do you guys know what is the directory transversal or ..dash attack?
Yes, it's a way to attack an application server by traversing to the folders and trying to teach write protection, write the enable permission.
This is a demonstration of Wirecast.
Later on, serve to the end user.
Exactly. Okay, yeah, as colleagues said, directory transversal is an HTTP exploit which allows attackers to access restricted directories and execute commands outside of the web server root directory. So web server provides two main level of security mechanisms. That's access control lists,
This is
and
a
that's root directory.
demonstration of Wirecast.
In web application dynamic pages, input usually is received from browser through get and post request. You have some other methods, but let's keep it simple. So, if you make a request, get testwebsite.com, show ASP, and access old archive, blah, 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 and make the request like this, HTTP://, host that website, browser request, the dynamic page, that
This is a
show page,
demonstration of
to
Wirecast.
actually go to server and take old archive HTML page. If the attacker assume that that show ASP can actually retrieve files from anywhere else, even in the restricted areas, all the attacker needs to do is to actually add ..dash to actually go up in the root directory until the system INI or user database or whatever it is.
This is a demonstration of Wirecast.
So that's the difference. It's a guess game for attacker to know how much dot dot dashes it needs to be put. However, in that guess game, by trial and error, you can fairly fast. It cannot be 100 directories under, so
This is a
fairly fast you
demonstration
can
of
actually access
Wirecast.
restricted data, sensitive information, and stuff like that. Anybody know, looking at you, how do we actually protect ourselves from dot dot dash?
By limiting the security only to the underneath folders of the application first. So that would be the implementation of the principle of least privilege, where only the least level of privilege is allowed to file instead.
Over cool, Jackie.
This is a demonstration
National
of
banner.
Wirecast.
Опа, Jackie. Ti dobro. Ništa, nema veze. Okay, so that is true actually. We're limiting access to the least, to the lowest level, and actually are denying pages to have access to content, and we have a list of
This
stuff
is
that
a
some page can
demonstration
actually
of
access.
Wirecast.
The other thing is shell shock. It's a vulnerability affecting bash. That's a common component in like 85% of the internet. And every Linux system, every Unix system, every Android smartphone, every Apple smartphone, every Apache, every IIS, and every Windows with Cygwin installed are actually affected by shell shock. What is shell shock?
This is a demonstration of Wirecast.
Okay. Shell shock is exploit of the bash. It was actual zero-day attack. It's exploit of the bash common structure in code. So once you have a bash code that says environment val and common sentence, and then you have bash c echo real command, the attacker can easily, fairly easily, access and put after the bash structure can put echo unexpected command. If it's before the bash command, once it's ran, real command gets executed after the malicious code. It cannot actually gain root access to the system itself, as bash does not have root
This
privileges.
is a demonstration
But it has
of
super user
Wirecast.
or sudo privileges, so that's a problem. If attacker get a hold of your console, you have a serious problem, because the easiest thing to do is to make a redirect, and you have a problem. Everything goes through attacker's website from them. From shell shock, we have a different ways to actually fight it. Apple has the most creative one. Apple said, no, our users are not affected.
This is a demonstration
how,
of
but they said
Wirecast.
But the actual way to prevent it is to make some kind of adjustments to the bash that reads the whole command and doesn't allow you to execute anything before actual bash script. So, next thing, that's the third one, and the fourth one will be most interesting for me.
This is a
For you, if
demonstration
you're-
of Wirecast.
If you're bored, I'm just hoping that you're having a nice sleep, nap time and everything. I'm trying not to talk very loud, so. Okay, the next one is heartbeats. It's not heartbeats, it's heartbleed. So heartbleed is also, it happened like 2 years ago, then after that it happened shell shock. Heartbleed was the most serious impact on security community that happened in the past 20
This
years,
is a demonstration of
including
Wirecast.
WikiLeaks and NORAD hacking and everything. Heartbleed was the first actual practical way to strip down the SSL on random server. So, for SSL to work, your computer needs to communicate with server all the time. It sends something called heartbeats. That heartbeats are actually informing the server that client is online. So
This
it
is a
works like
demonstration
I'm
of
sending you
Wirecast.
request, hello server, are you there? And it's responding me, I'm there. If the user is actually sending server request command, like hi server, if you're there, give me a word hat, 3 characters. So the server says, I'm fine, here it is, hat, 3 characters. Okay, next time I'm sending another request, give me watch, response, 5 letters, never mind, maybe it's
This is a
5 letters,
demonstration
huh.
of Wirecast.
Give me 5 letters, watch. It responds, yes, I'm alive, 5 letters, watch. Next time, it goes like this. Give me 5 letters, give me 5 letters, give me phone, 500 letters. And the servers get confused. It responds, of course, with 5 letters that you requested for. But after that, you have 500 more,
This is a demonstration
495,
of Wirecast.
or 64 kilobytes in response directly from the server via sending the malicious request. So every action, every log that server has in the SSL is getting in the response. So you have, okay, we start with phone that we requested for, then we have the user 123, whatever it is, try to change password from this password to that password, whatever it can go into 64 kilobits, it gets response
This
via
is a
clear text
demonstration of
without
Wirecast.
SSL protection. This was an issue in the signature of the SSL certificate, OpenSSL, which is the most popular at the moment. And the TLS heartbeats can be sent from the either side of the connection, so it's not actually only the server exploit, it's actual SSL exploit. So the only way to protect from that is implementation of TLS 1.2, which is the newest one, which is the only one unbroken so far.
This is a demonstration
This
of
one
Wirecast.
actually doesn't have a limit on requests, so if I don't get what I'm looking for in the first response, I can do it numbers of times, I can do it how many times I want, and until I get what I have, and there is no way to track it. I mentioned, we have always checklist, and we always need to practice in lab environment and never use the tool first time on the client side, but if we know that we don't know all the attacks,
Demonstration of
and
Wirecast.
the most penetration testers use lists to make that. These 3 attacks and the 4th one happened in the past 2 years. They're not on any list. They're not even taught at SANS Institute. They are listed on some security forums, community, stuff like that. But most of those lists are outdated, are not regularly updated,
This is a
are
demonstration
not
of Wirecast.
precise enough, stuff like that. So if we don't know all the attacks, we just need the mindset and try to exploit stuff like anything. So we need to have another one, and this is the last one, which offers the actual solution. So we all know what the hash is, yeah? Okay, cool. So let's keep it on Windows, because it's easier.
This is a demonstration of Wirecast.
Windows uses hashes, and it used to use only LM hashes, which is 16 characters. Now it uses NTLM, which is 2 times 16, to actually hash all the passwords and store it in the user database in System32. So let's keep it on Windows, and this was a known exploit of the Windows operating system. So at some point, you could actually switch on Windows 7, for instance, you could switch the command
This is a
CMD file
demonstration of Wirecast.
in the previous to name OSK. Yeah, OSK. Yeah. That's on-screen keyboard. So before you log in, you could actually go and click on-screen keyboard, faking that your keyboard is not working, and it will actually give you the command prompt without requirements for authentication. Yeah, that happened. That's still happening, by the way. However, they fixed something else. Then you could do a password dump, and take a hash
This
of
is a
all the
demonstration of
passwords in the
Wirecast.
system and log in as regular user. That's how it happened. It was reserved only for, it required for passwords to remain static, and it was reserved only for operating systems and local systems. However, somebody actually figured why not do that online. So the the normal flow of the web authentication is two. Firstly, present
This is a
authentication from user.
demonstration of
Then
Wirecast.
enter credentials, whatever it is, my username / secure password. Mine is 123 as usual. Then user press submit. Server receives credentials, my username, secure password. Server hashes the password to using some kind of hash logarithm. Now it's SHA-256, I think. Server compares username in the database and compares the password hash with the stored value. That's how it works.
This is a demonstration
At
of Wirecast.
this point, when you press submit, the TLS or the SSL is actually in charge of transferring the clear text to the server side of the process. Okay, we have arguments now, we have Heartbleed, but even before that, we had arguments against we have arguments against using of SSL or TLS. So it's bar mitzvah attack, there is CPU hit, there is
This
some
is a
kind of
demonstration
management.
of
It's
Wirecast.
expensive actually to maintain the TLS. So somebody made brilliant idea at some point, and now that became standard for some reason. And I'm talking to you, .NETs. Now it became standard to utilize actual hashing on the client side of the process. So now we have a form looking like this. No TLS, request form. Present authentication, enter credentials,
This
submit
is a
credentials.
demonstration of Wirecast.
Then browser intercepts the credentials, hashes the password, and sends the hash to the database, to the server. Server takes the credentials, compares username and hash value in the system. Anybody see the problem here? So hash is actively being the password. Okay, that's the problem one.
This is a demonstration of Wirecast.
You can steal the algorithm for the hash. Okay, fair enough, you can. Okay, first problem here is actually moving, like you said, is actually moving the hashing from server to client. When you do that, your password is not sent across the wire in clear text, yay, but the hash is becoming
This is a
the
demonstration
password
of
itself.
Wirecast.
So if I can steal your hash, I can always do it without actual need for your password. The hash and not the password is enough for the authentication mechanism. But if you send it only in clear text, you're actually denying the point of authentication. Next problem would be the new password is stored directly in the database. That's a problem if you actually dump the
This is a
database.
demonstration of Wirecast.
If you dump the database, you can use all the hashes, which then again can be used and sent to the
This is a demonstration
effectively
of
behaving
Wirecast.
as a password. But the new value that is getting there has to be protected. So to secure that hash, it needs to be salted, and we all know what salt the hash is, yeah? Okay. We all know what the salt hash is. So That salt is actually
This
notice
is a
the rainbow
demonstration
tables as
of
a mechanism
Wirecast.
for actual cracking the hash. And we all know what rainbow tables are. Okay, cool. Then, next problem with all this is people think that, and this is the worst part, actually. False sense of security is the deadliest thing that you can afford. That's the most expensive mistake you can make is the actual false sense of security. People think that they are secure because they have solved password security issues of transmitting and storing password in the clear. So at no point your password is actually transmitted via wire in clear text. The only good side of that is that if you're using the same password, and we all do, actually, if you're using the same password, you cannot actually retrieve it at no point. So only thing I can have is the actual hash value, and that's good. The other side, you cannot actually hash,
Demonstration of Wirecast.
solve the hash in the client side. So solution to the problem would be, realistic solution, not expensive, is to properly implement the TLS and HTTP strict transfer security, ASTS, along with salted password and represented and stored in the database on the backend, all the time. So
This
TLS
is a
will
demonstration of Wirecast.
protect the credentials on the wire. HTST will tell the client to use TLS on all visits to the site. It solves the problem of salting hash because the only way to solve the hash on the client side is to use the actual username or email to salt it. Then there is no point of salting it. And rainbow tables are neutralized, and window of the problem could only be the first time creating the password, while actually first time
This is a
sending the
demonstration of
request to the server,
Wirecast.
because that's viable to SSL stripping, because that's, well, no app is 100% safe. So, thing is, do not attempt, ever, and it's fun, I know, but do not do it, to develop your own password hashing code. That's too easy not to do it right. That course you had, I believe that you all study mathematics or IT. So that course in cryptography you had
This is
in
a
first year does
demonstration
not
of
make you
Wirecast.
actual expert. It's not going to happen. It's a solved problem, already solved problem. So use PHP, Bash, or Blipsodium, or whatever implementation you seem fit. There are a lot of them. Always hash on server side. Do not use short salt. Ideally, it should always be the output should be the size of the hash function. So the output of the SHA-256 is 32 bytes. So salt should be 32
This is a
random bytes.
demonstration of Wirecast.
Same as the password in the value. When I was making this presentation, these are terrible ideas how to actually hash password more securely. The problem is you have a limited amount. If your hash always has a same output, same size of the output, you have a limited amount of combination in that. Eventually, something's going to overlap. But these are ridiculously stupid implementation. Let's call it that way.
This is a
So you
demonstration
use
of Wirecast.
MD5, which is used only for checksum, to hash already hashed password with SHA-1 for some reason. So if I can get hold of your hash, I can make a problem, no matter how you hash it. The only not broken hashing algorithm so far is SHA-256 and SHA-2. We call it that way.
This
And
is a
there is already
demonstration
SHA-3
of Wirecast.
developed and waiting for SHA-2 to be broken. I mean, that's already solved. Proper way to store password is to generate long random string using CSSpring. I use CSSpring, use whatever you want. Prepend salt to the password with standard crypto hash function, and then save both salt and password in the database as a single entry. So proper way to validate that password would be to retrieve
is a
the user
demonstration of
salt and
Wirecast.
hash from the database, prepend salt to the given password, and then hash it using the same function. Compare the hash of the given password to the hash from the database. If it's okay, you're good to go. If it's not okay, you have a problem. Or say expected answer is this, and screw it, have it. So that's, I think, it from me. Any questions?
This is a demonstration of Wirecast.
Just a recommendation that I'd like to give. What you provided in this presentation is more detailed black box configuration method. And what I'd like to recommend to everyone is also the white box configuration, which translated is just general analysis of your source code. So if you analyze the source code, it will give a lot of information and possible pinpoint.
This is a demonstration of Wirecast.
Just by analyzing your source code, you will receive information, for instance, for the knowledge service attacks, possible maybe injection points, and so on.
True. That is true, but you're not always going to have access to the code. It's okay if you're actually testing your own application. If you're testing somebody else's application, then you have a problem. Nobody's going to give you the whole code.
Demonstration of Wirecast.
And then you have actual problem. And actually analyzing the code takes a lot of time. If you do it manually, if you go through the code, it takes weeks for a decent size app, it takes weeks to actually go through.
I agree.
What is rainbow table? Okay, a rainbow table is, since the hash is always using the same function to hash any password, and
This
all the
is a
password has
demonstration of Wirecast.
same output value. So you're limited to, let's say, 32 characters. Or let's drop it down. You're limited to 16 in NTLM. Rainbow table is a generator that will generate every password in the range, and then actively try to brute force not the authentication system, but the hash itself. So you have pre-stored values of the hash, then you try to compare it and see what is it, because the hash is one-way function, that's the point.
This is a
Hash cannot be
demonstration of Wirecast.
reverted, because there is a way for two different entries to have the same hash. There is a possibility. It rarely happens, but it is a possibility. So when you have a rainbow table, it's actually the list of predefined words and hash values for them that you can check in the system. Salting is adding random value to the
This
hash.
is a demonstration
So
of Wirecast.
if I get a hold of your password as such, or the hash value of your password, I have a problem to actually, if I get a hold of your database entry of that, I can use rainbow table to broke your password. Okay. If I add salt to the password, random string, which is 10 characters, and append it to your password, and hash it, then the whole string is getting hashed.
This is a demonstration
Even
of
if you have a
Wirecast.
rainbow table, there is no possible way to actually retrieve the full value of the password, because you have something else that's being hashed with your password. The database actually takes the string, prepend it to the password, and make a new hash using the same function. If it's not the same, if the output is not the same, you're not good to go. Anything else?
This is a demonstration of Wirecast.
But if you're hashing on the server side, there is nothing you can do with that hash. So if you send it to me, I'm again gonna hash it, and try to compare it like that. So then there you have a problem. If you find a way to bypass the
This is a
authentication
demonstration of
of
Wirecast.
the hash itself, then there is no need to take my hash. I mean, if that's the loophole, there is a problem. But the point is, when you make a drop table, there is nothing that you can get from it. So my usernames are visible. Okay, super. It's a problem, but there is no password that you can actually retrieve, because the only thing you have is already processed information. So that's why it's...
This is a demonstration of
Anything else?
Wirecast.
So that's it.
This is a demonstration of